dipoles. One is magnetic dipole, other is electric dipole. Let us understand what are them and the concepts later. Electric dipole, it is a recap. Let me resume in brief as it is already taught. Electric dipole is equal and opposite charges separated by distance. There are two electric poles of equal and opposite and are separated by distance. Here the distance of separation is 2L. From the center, the distance of separation are L on either side. Q is the magnitude of the electric pole strength. Same magnitude. Opposite means if one carries negative charge, other carry positive charge. Electric field strength is same as magnitude of the charge they possess. Q is the amount of charge, Q is the amount of charge. Both are same, equal. And these two are separated by distance 2L. It is called as electric dipole. Equal and opposite. Electric poles of equal and opposite. What is magnetic dipole? Magnetic dipole is similar to this. There are two poles of equal and opposite. The poles are magnetic poles. Here the poles are electric poles. Magnetic poles are, one is north pole, other is south pole. Equal in magnitude means same pole strength. We have N pole and north pole and south pole. They are equal in magnitude. They are equal in the strength of the pole. It is magnetic pole strength, M, given by the symbol M. It is not like the charge. What is meant by the pole strength? The pole strength, it is a force, magnetic force, which is acted on other magnetic material, which may be the force of attraction or force of repulsion. That force of repulsion or attraction is called as strength of the magnetic pole. That is pole strength of the magnet. They are equal in strength. But opposite means what is it? What is the meaning of opposite? If this pole is attracting that magnet, this pole will repel that magnet like that. Opposite in the sense. Same magnitude means same strength, pole strength. They have same force of attraction or repulsion on the magnet if you bring near them. That is called as pole strength. The pole strength also specify the strength of the magnetic field or magnetic strength, the strength of the magnet. And this is called as magnetic dipole, it is called as electric dipole. The two poles are separated by distance of 2L. The two poles are separated by distance of 2L. From the center, at a distance of L, they are separated on either side. 2L is the distance of separation. M is the pole strength. That is called as magnetic dipole. The example for magnetic dipole is a magnet, bar magnet or any magnetic material. It, any magnet always has two poles, dipoles. One is north pole and south pole. It cannot have a single pole like either north pole or south pole, because if you break this at this point, again two pieces of north and south, like that, break any number of times, always a piece has two dipole. That is in nature, that we cannot have a single monopole. Magnet cannot have a monopole. Magnet will always have a dipole like this. And it is called as magnetic dipole, it is called as electric dipole. Example for magnetic dipole is any magnet, macroscopic. Macroscopic means it contains billions of atoms and molecules. Solid material, magnetic dipole. Permanent magnet is an example. Example for electric dipole is of course microscopic, a single molecule. Example is HCl molecule. H carries positive charge, Cl carries negative charge. The distance of separation is the bond length between Cl and HCl. That is a microscopic, of course. And this electric dipole and magnetic dipole both are existing in nature. If these two dipoles are present, we come across the term magnetic dipole moment and electric dipole moment. The symbol is given by P, the symbol is given by M. What is the definition for this momentum, electric dipole momentum and magnetic dipole momentum? This already we know that P means vector quantity. It has both magnitude and direction. It has both magnitude and direction. Magnitude of P is given by Q, both of them are same, into distance of separation 2L, Q into 2L. And what is the direction of P? Direction of P is a line representing the direction from minus Q to plus Q. It is along this line or parallel to the line like this. Indicates the direction of this P. This indicates the magnitude of P. Electric dipole moment. What is the definition for M? It is also a vector, both magnitude and direction. The magnitude is M. You can take either this, both of them are same. The pole strength and distance of separation of the two poles, 2L. This gives the magnitude of M. If that is the case, what would be the direction of M? The direction of M is from south to north, inside the material. This line represents magnetic line of force in the magnetic material. It is a permanent magnet, south pole and north pole. If there is a magnet, there are magnetic lines of force which realizes the magnetic field or magnetic field strength of the magnet. The magnetic lines are of two types, inside and outside. Inside, the direction is from south to north. In the material, there are magnetic lines of force in the straight line like this, from south pole to north pole. And outside the magnet, that is space surrounding the magnet, there are also magnetic field or magnetic lines of force. These are the magnetic lines of force. And the direction is from north to south. There is all surrounding what is that? Magnetic lines of force. outside, the direction of M, it is not these lines. This line will will indicate the direction of M. Direction of M from south to north. Direction of M is the magnetic lines which are originated is emerging from S and merging at N inside the material. That is the direction of magnetic dipole momentum. It is about the permanent magnet. It is about the dipole, electric dipole. As you know, when you break this, example, a molecule like Cl, when you break the bond, they are isolated as ions, negative ions, Cl minus and H plus ions. So this electric monopole can exist in nature, but magnetic monopole does not exist. They are always in dipole. It is never. It is of course a macroscopic material. It is a microscopic material. What is the meaning of this? There is some definition is there. Magnetic momentum, that is magnetic dipole momentum, electric dipole momentum, P dash M dash. It has magnitude and direction. It has magnitude and direction. What does it describe? When you apply magnetic field, external magnetic field on this magnet, similarly, external electric field on this dipole. This dipole has its own electric field. This dipole has its own magnetic field. Let us apply external magnetic field. External electric field. It has its own directions. What will happen? There will be a tendency of alignment of this magnetic moment along the direction of the applied magnetic field. Tendency of line up. What line up? This line up along the direction of the magnetic field. The tendency is there. Similarly, we have tendency of alignment of this, or tendency of line up along the applied electric field. The tendency will be there. As used, what is that? Tends to align themselves. Tend to align themselves in the same direction. That is dipole moment and field. Dipole moment and the field. Which causes this consequence will stir up the material. What is a stir up? This magnet gets rotated, or this dipole gets rotated in the field. That is rotation because tending to align the directions of the M and the magnetic field applied and direction of P along the electric field applied.